Example 1. Test whether the following sequences are arithmetic progressions, APs. Part A, 5, 9, 13, 17, and so on. Now a sequence is arithmetic if Tn plus 1 minus Tn is equal to Tn minus Tn minus 1. So if we choose any three consecutive terms of the sequence, let's say for example in this case we chose 17. We did 17 minus 13 and then compared that with 13 minus 9. So the difference between these two terms and the difference between these two terms should be identical, common difference. 17 minus 13 equals 4 and 13 minus 9 also equals 4. So therefore the sequence is arithmetic. Let's have a look at part B. 2, 3, 5, 8 and so on. Again, just choose any three consecutive terms. So I've chosen 2, 3 and 5 and compared the difference between those three terms. So comparing 3 and 5, 5 minus 3 is 2. And comparing 3 and 2, 3 minus 2 is equal to 1. Obviously, it's not a common difference since the difference between 2 and 3 is not the same as the difference between 3 and 5. Therefore, the sequence is not arithmetic. Now, just as a side note, if we go back to what was written here in red, and we made Tn the subject of the formula, then what you end up with is the average of two terms. So let's say we chose a term and we looked at the terms on either side of it, so Tn plus 1 and Tn minus 1, and we took the average of those, it should equal the term in between. So in this case, let's say for example, the average of 5 and 13, so 5 plus 13 is 18, divided by 2 equals 9, and that equals the term in between. So basically it's just a rearrangement of this definition here, but it is another useful way to show if a sequence is arithmetic or not. Let's have a look at another interesting example. So part C, we have this sequence, ln of 2, ln of 4, ln of 8, ln of 16, and so on. Now, just initially, it doesn't look like it's an arithmetic progression. In other words, just due to the nature of the numbers themselves, 2, 4, 8, 16, they themselves are not arithmetic since the difference between them, it's not common, it's not the same. However, using one of our logarithm laws, in fact, we use the law number 3, where we express the number inside the logarithm here as a power. So 2 is 2 to the power of 1, 4 is 2 to the power of 2, 8 is 2 cubed, and 16 is 2 to the power of 4, of course, and so on. And applying the log law number 3, where we take the index and bring it out to the front, this sequence can be rewritten as ln of 2, 2 ln of 2, 3 ln of 2, 4 ln of 2, and so on. Now again, choosing any three consecutive terms. So for example, 4 ln 2 minus 3 ln 2, and just working out the difference, and that's just ln of 2. And then comparing it with the difference of 3 ln of 2 minus 2 ln of 2. And of course, that's also equal to ln of 2, so there's a common difference there. So therefore, the sequence is arithmetic. Example 2. Find the first negative term of the AP with A equals 151 and D equals negative 3. Firstly, let's write out the first few terms of the AP, just so we can see a pattern. Now, A represents the first term and D represents the common difference. So that's the difference between any two consecutive terms. So starting off with 151, subtract 3, one lot of common difference there. 151 minus 3 is 148. 148 minus 3 is 145, 145 minus 3 is 142, and so on. Next, let's determine a formula for the nth term Tn. Starting with the general formula here, Tn equals A plus n minus 1d. So Tn equals the first term, which is 151, plus n minus 1 multiplied by the common difference of negative 3. So substituting in those two values into the general formula here, we have Tn equals 151 plus n minus 1 multiplied by negative 3. So let's expand the brackets and simplify the algebra. We have Tn equals 151 minus 3n plus 3. That's negative 1 multiplied by negative 3. Gives us the positive 3 there. And collecting like terms, we have Tn equals 154 minus 3n. Lastly, let's solve for n by letting Tn less than 0, or setting Tn as Tn less than 0. After all, the question does ask for finding the first negative term of the AP, hence why we set Tn less than 0 there. So let's form the inequality. Okay, so we'll take our general formula here for this particular AP, so the term for, to find the nth term, that is, 154 minus 3n less than 0. Subtracting 154 from both sides, so we'll make negative 3n the subject of the formula, so negative 3n is less than negative 154. Next, we divide both sides by negative 3, and in doing so, we need to flip the inequality sign. So instead of it being less than, it now becomes greater than. So n is greater than 154 over 3, and just expressing that as a mixed numeral, n is greater than 51 and a third. So we need the next integer, or an integer that is higher than 51 and a third, of course. So the next integer along is n equals 52, which means that's the 52nd term. That is the first negative term of this AP. So t of 52 is equal to 154 minus 3 times 52. So going back to our formula for the nth term of this particular AP. And we have the 52nd term, t 52, is equal to negative 2. Example 3. How many terms are there in the arithmetic progression 15, 26, 37, ... 6,395? Now, firstly, we don't need to prove that this is an arithmetic progression. We're told so in the question, so we can find the common difference just by taking any two consecutive terms. So just be mindful that there may be questions where you may need to prove that this is an arithmetic progression first by comparing any three consecutive terms and comparing the common differences. But in this case, we're told it's an AP, just take any two consecutive terms, subtract one from the other to find the common difference. So in this case, determining the formula for Tn, or the nth term of this AP, we have a equals 15, our first term, and the common difference is found by taking any term and then subtracting the term before it. So for example, 37 minus 26 gives us 11. Substituting in those two values into the general formula for the nth term of an AP. So Tn equals 15 plus n minus 1 multiplied by 11. So that's from a plus n minus 1 multiplied by d. Expanding the brackets, we have Tn equals 15 plus 11n minus 11. And combining the like terms, so 15 minus 11 of course is 4. We have Tn equals 11n plus 4. Now, 6,395 represents the last term, so we'd like to find the value of n that corresponds to this particular term here. So we're going to solve for n, given that Tn, our last term, is 6,395. So let's solve for n here, given 11n plus 4 equals 6,395. And of course, we're going to make n the subject of the formula. So subtracting 4 from both sides, we have 11n equals 6,391. Next, we're going to divide both sides by 11 to make n the subject of the formula. So n equals 6,391 divided by 11, and we have n equals 581. So interpreting this result, what this means is that this particular AP has 581 terms. Example 4. Write out the first 5 terms of an AP, given the 10th term, T10 equals 52, and the 17th term, T17 equals 31. Now the strategy here is to form two equations involving the nth term of an AP, and applying the fact that T10 equals 52 and T17 equals 31, so one for each equation, and then solve those equations simultaneously to find the first term A and the common difference D. Then we can write out the first 5 terms of this particular AP. So for equation 1, I'm using the fact that T10, or the 10th term, equals 52, so that means n equals 10. So 52 is equal to A plus 10 minus 1 times D. And the second equation uses the fact that T17 equals 31, so the 17th term, n equals 17 of course. 31 equals A plus 17 minus 1 D. Then we're going to solve simultaneously by elimination. So equation 1 minus equation 2, So 52 minus 31 is 21. A minus A is 0, so those two are eliminated there. And then we have 9D minus 16D. So we have 21 equals negative 7D. Dividing both sides by negative 7, we have D equals negative 3. So that's the common difference. So next, to find A, so we can use either one of these two equations. Substitute D equals negative 3 in either one. So I've just used equation 1 just for convenience. 52 equals A plus 9 times negative 3. 52 equals A minus 27. Adding 27 to both sides, we have A equals 79. So now we can form an equation for the nth term of this particular AP. So Tn equals 79 plus n minus 1 times negative 3. Expanding the brackets and collecting like terms, we have Tn equals 82 minus 3n. Now we can write the first 5 terms of this particular AP. So the first 5 terms of the AP are 79, 76, 73, 70, and 67.